just ask it. Just be like, hey Claude, how do I use you for programming? You seem to be doing a very bad job and not understanding my project at all. What can I do to make you work better? How to use AI for programming. Step 1, don't. Just kidding. Sorry, haters. So as AI in software engineering continues to be like the most controversial topic in decades when it comes to this field, I've already made a couple of videos about it, starting with my thoughts on AI. I recommend you guys watch that video to just get a little bit of context. But today I wanted to talk a bit more specifically, a bit more practically on how I think you should use AI for programming. Just to establish a little bit of context, again, I highly recommend you watch the video on my thoughts about AI because I don't want to spend too much time on that here today. A little bit of context is that people seem to get vastly different results when they use AI for programming. That has to make you wonder, is the problem the AI or is the problem you? I think part of the problem is that some people may have been sold the idea that AI is supposed to just take the workload off of you. It's supposed to just be the work version of you so that you can be on a holiday somewhere on some island. That's not true. That's not how it is today. I don't know what the future would be like. I wouldn't mind being on some island, but I am here in my little office. I still end up working quite a bit. So of course, if you've been sold this idea that it is the one doing everything, it's the only one that possesses any intelligence in the task that I'm actually trying to achieve, you're probably not gonna have a good time. But if you are a skilled professional using it as a tool, you can achieve a lot. I mean, to be honest, it's almost like any skill in life. Oh, I'm trying to play basketball. I can't get the ball in the hoop. The ball must be the problem. The problem might just be with you, buddy. The problem might just be with you. So at the moment, the way that things are halfway through 2026, you still need to be smart. You still need to be a good engineer to get really good results out of using AI. I keep saying at the moment, and I keep dropping a little time reference because things can change. In the future, in a few years, maybe you can just say, make GTA 6 and you will get a perfect game. But here we are, living in today. So that's what we're gonna talk about. So when some people get really good results with AI and they go on about how amazing it is, and some people get very bad results with AI and say that it is the worst thing ever and they refuse to touch it, you have to wonder why there's such a dichotomy. And so let me clear this up for you. Is AI actually good for programming? The answer, yes. And even though, as I always say, all of the videos on this channel are entirely my humble opinion, which you can feel free to disagree with, I think that AI is objectively good at programming. Sorry. And of course, I'm talking about the best models that are currently available. So something like Claude Opus, GPT Codex, and the rest of the models that I don't use very often at all. Is it perfect? No. I never said it was perfect, I said it was good. And so if you are finding that it is not good and it isn't performing very well for you, then that might just be on you, mate. But don't worry, that's why I'm here, not just with this video, but with an entire series about game engine development in which we're going to be heavily leaning on AI to be super productive. And guess what? It's still gonna be a super good product. I promise you that. And so today, I'm just gonna show you some of the things that I do to get better results from using AI for programming. I'm going to practically show you what to do. But whilst this will definitely make AI work better for you, this doesn't replace you. This doesn't replace the fact that you need to actually be good and also understand what's going on and be the one directing it. You can't just stop learning and stop trying to be an engineer and offload it to AI. That's just not going to work at this point in time. And that's why I keep saying it's a tool. It's a tool. It's not a replacement, it's a tool. So make sure that you are still continuing to learn. And if you want to learn Rust, then check out Let's Get Rusty, the sponsor of this video. If you are into programming low-level systems or game engines, you have almost certainly heard of Rust. But if you're like me, you've probably put off learning it. Well, that could end today because Let's Get Rusty focuses on Rust education and job-ready training. And it's also made by a fellow YouTuber with a YouTube channel all about Rust. Rust is a really interesting language. It's got all this low-level control and performance that you'd find in a language like C or C++, but it tries to build on some of the major pitfalls of those languages. You know, like the whole safety situation. So Rust builds on that with modern tooling and strong safety guarantees, so you can write multi-threaded code without worrying about burning everything to the ground because you made a small mistake. And that's exactly why companies like Google, Microsoft, and Amazon are adopting it more and more in production. And it also keeps topping Stack Overflow's most admired language year after year. Let's Get Rusty runs structured programs for individuals and teams, and they've helped thousands of developers over the years actually get productive with Rust, not just watch a bunch of videos and forget everything a week later. So go to letsgetrusty.com/start with Cherno, link will be in the description below, and find out more about their training. Huge thank you to Let's Get Rusty for sponsoring this video. Okay, so how do you use AI for programming? How do you actually make it good? We're gonna jump in a moment and have a look at some specifics, but let me just say this, because then you might not have to watch the rest of this video. Just ask it. Just be like, hey Claude, how do I use you for programming? You seem to be doing a very bad job and not understanding my project at all. What can I do to make you work better? See, AI is meant to be this whole natural language interface, right? It's supposed to be a way for you to speak English or whatever language you speak directly to the computer, and then it kind of understands that, and that's sort of its technical basis, not just like, I don't know, some JSON file with numbers. So since it has that like natural language interface, and since the idea is it's supposed to be like a human, like an engineer on your team, why don't you just speak to it like an engineer and say, how do I use you better? How do I utilize more of what you have, and why do you keep getting things like this wrong? What can I do about it? Because seriously, even though I'm going to show you a few things that you can actually do, if you just ask it that, it will probably just tell you what I'm about to tell you now. It's not going to go into the details of my experience and how I made these conclusions, and that's probably the value that I'm going to hopefully give you with the rest of this video. But that's a really good starting point. And to be honest, that's a really good way to actually use AI. Don't just start telling it, do this, do that, change that, implement this feature. Be like, how do I get you to do this in a high quality way that I'm going to be happy with at the end? That's it. I bet if you did that, that would just improve it dramatically. Anyway, if you're still here, thank you. Let me tell you a bit more about my experience using AI over the months. So I have been personally using it in the context of game engine development, specifically building a robotics simulator that is basically a game engine. It's called Lucky Engine. It's based on Hazel. You can find out much more information and even download it and play around with it by going to luckyrobots.com. So we have been very heavily using AI, specifically Claude is the one we settled on, for the last 6+ months with a team of mostly senior engineers. And I have to say that it has dramatically changed the way that programming is done. It has dramatically increased our productivity. Now, I want you to pay attention to the fact that I said senior engineers mostly. Every single software engineer on my team is a good programmer. They are all excellent programmers. If they were not, I don't think this would work anywhere near as well as it has worked out. And that's really important because this is where that whole like your mileage may vary situation comes in. Why are some people having great success with it? Why are some people not? Because I think it's sort of weeding out the software engineers that actually understand how software is built and how to architect things and what things are going to be a problem in the future if left as is, and the ones that maybe just lack the experience. It's not like their heart is in the wrong place, but maybe they just physically lack the experience to discern between good and evil, which is completely understandable. This is not a level playing field. It's like showing someone a research paper and getting two different engineers to implement it. One might come up with a brilliant optimized implementation, and one might not even be able to get it to run properly, or it might not have the correct outputs in 50% of the cases. You can't compare these things, but I can safely say that, again, in my experience working on this game engine with a team of mostly senior engineers, it has been good. Overall, it's been a massive net positive. We've achieved a lot more in the last 6 or so months than we otherwise would have if AI wasn't a thing. Like, it's quite amazing, to be completely honest. I think it's also fundamentally changed the way that computer science is done, right? Because computer science is science. A lot of it is theoretical. But one of the things that I keep saying about computer science is that it can and should be extremely practical. Like when people ask me about performance or optimization, or you've probably heard me mention this a lot throughout my C++ series, if you go back and watch that, or if you have already seen it, stop assuming and just do it. Stop being like, yeah, this is going to be faster than this, or this is slow. Just test it. This is not some like lab experiment in which you need to order chemicals and make sure you're in a lab to do something. You have a computer, you have a laptop, write some code, test it, see what happens, do some benchmarks. As long as you do that part correctly, you will know, at least on your computer, on your architecture, how that actually performs. So this whole thing of me telling people to stop being so theoretical and start being a bit more practical, AI has like turned that up to 11, right? Because things that otherwise just would have taken too long to just prove or to actually physically write out the code and make the system work so that you can test it, you can just do like that. You can just be like, hey, I have this idea, like maybe we should do it this way, maybe that will be faster. You just tell it that, it writes all the code for you, it prepares all the benchmarks, it runs them, you have the data. You now have the data that might have taken you like a week to actually go through, and a background agent just worked on it for a while and it's done now. Right? It's even more practical now and even less theoretical. And because you can really have as many agents as you like it's not like you're using AI to do one thing at a time. You might have some like major feature project that you're working on that you really want to get right, and it's not just like some background research, right? It's like your primary thing you're working on, and for that you might want to have, one kind of agent that you're really focused on. But you might have like 4 different agents just doing background research and trying things. What if we did this? What if we did that? You can have a dual of that. And of course, when it comes down to like looking at these numbers and looking at these benchmarks, you still should read the code that the AI agent wrote to be like, is that even correct? Did it do a good job? But the thing is, it's science. So you can kind of make sure that you have these inputs, these outputs, test benches, everything's like tested, sanitized, verified. You can have it do that. You can have it write your C++ code for your, engine system, but then have like Python harnesses to like run that, execute it, test it, compare it. Like you can set up this full kind of suite of tools that is sort of keeping it in check. And then you just wind up with it on its own doing all this background work that lets you be more practical and not just theoretically think about it in a boardroom with a whiteboard and a bunch of engineers being like, well, should we do it this way? Should we architect it this way? Is this going to be faster or not? So the fact that it allows you to actually test without just theorizing is a massive game changer. And now let's actually have a look at it. I'll show you some of the things that I do to make it much better. But again, there's a lot. I'm going to try and just show you the things that potentially have the biggest impact and are relatively simple to set up. Otherwise, there's no way that it would fit into one video. But again, this is why we have this new game engine series where we're going to develop a whole project, because I think a lot will come out of that compared to this sort of jumpstart summary. Okay, so here we have an example directory. Let's literally just go through what I do. Control L, WT, Enter. This opens up my terminal. Why is it WT? Because WT is Windows Terminal. I have configured Windows Terminal, which is like the built-in terminal manager thing that comes with Windows 11, to use PowerShell 7. Now, why PowerShell? Why not Command Prompt? Why not some other terminal emulator? Why not use something fancy that gives me like translucent frosted glass effects and allows me to split my terminal into as many windows as I want? I don't know. I guess I'm just happy with the simple, more native terminal experience on Windows. It gets the job done. It doesn't get in my way. I don't have to spend hours setting it up. Windows is kind of built to work with PowerShell, so it just works quite well. Anyway, this isn't a terminal video, but I just thought I would explain why specifically this setup. But as you can see, I can just type WT in any directory, open up PowerShell at that directory, and from here, I can just type Claude, hit enter, and I'm in. Now, the first thing I want to talk about is model. Which model should you use? As you can see, I've been trying out Fable. I would probably say that Opus 4.8 is, in my opinion, currently a good model to use. Fable just takes a very long time, and unless you're actually working on something super hard, I don't really see the benefit of it, to be honest. And also, this is Fable after they brought it back, because they took it away because of that whole US government thing, which we won't talk about here. They took it away and now they're giving it back to us. And I don't know, man, I swear it's different. I swear that the first time they gave it to us, it was just better. Now it just seems like it takes way longer than Opus and uses more tokens and doesn't really give me a result to justify that. So we're just gonna stick with Opus for now. What about effort? Because there are many different efforts that you can use. I generally work on X high unless like it's not working out, and then I probably switch to max. I don't think I've ever tried ultra code. Look at that though, pretty cool. But this is really the your mileage may vary scenario, right? Because it depends what you're working on. And actually, let me mention something really important here. The problem with trying to make a video like this is it depends what you're doing. It depends entirely on what kind of project you're working on and at what level as well. That's why I made a point of mentioning that I'm working on like a robotics simulation game engine. That is a pretty complicated project compared to, I don't know, a web app. No offense. There is no way that you can like equate those workflows. Like I feel like it wouldn't make sense. And also the capability of an AI agent like Claude is probably a lot more in that scenario, not just because it's, you know, objectively easier to write a web app. Again, no offense, sincerely. It's also because there's a lot more available training data for AI when it comes to web apps. It's just a popular way of making simple applications these days. If you compare that to game engines, and especially robotics simulators, which is like, you know, an entirely new industry, of course the experience is going to be completely different, and the capability of the AI agents is also going to be completely different. That's why as we start this new game engine series, you'll see that my approach with using AI agents is very hands-on. There are lots of people who let Claude literally run all night and they have just like a team of agents. Literally, it's like their team of engineers and they are just doing every part of the pipeline. And it's kind of gotten to the point where a lot of engineers have actually stopped reviewing code that is coming out of these agents because, you know, as long as you've got like the right sort of workflow, the right pipeline, the right tests and everything in place, they've sort of been able to just increase their output dramatically by not reading every line of code in every PR. That is not my approach. That is not my approach when building something like a simulation game engine. Because quite simply put, the level of quality that I'm seeing coming out of frontier AI models these days is not reliable and not good enough to just blindly trust. Like that's not going to happen at the moment. So I want to make it clear, and you can probably notice I'm being very careful with this video, that my workflow and my team's workflow that currently works pretty well for us is, yes, to use Claude a lot, but we are still reading every single line of code and we are very much micromanaging it. We're not just letting it run endlessly and do stuff without being aware of what it's doing. That doesn't mean that we never let it run overnight or do like long horizon tasks or implement entire, I don't know, experiments or research things that we're working on. We do, but before that code makes it into production, we refine it a lot, again using Claude, and we make sure that we're aware of everything that's written. And there are lots of ways to sort of verify, you know, what it's written, and we'll talk about some of them here. Okay, so let's start again. As I mentioned, the first thing that you can realistically do that doesn't really require me to like tell you step by step what to do is just to ask it, how do I use you best for my purpose? How can I use Claude optimally to help me create a high quality, high performance game engine? I want to establish proper workflows and minimize mistakes. That's it. Let's just see what this does. While that's thinking, you'll also note that I am using Claude Code in the CLI. I'm using it in the terminal. There is a desktop app. I don't really use it too much. I like this whole terminal thing. I can open another one. Obviously, I can have multiple of these docked wherever I like. I can have them side by side. I've got this vertical monitor here. I usually have like at least sort of 2 there. I can split up more on other monitors if I like. They're often working on different physical copies of various branches of the project that I'm working on. I don't really use Git work trees too much. I don't know why. I don't really have a good answer for that. I just like having multiple checkouts of my repository. And then usually it's like set to different branches. It might not even be. I might have 2 checkouts of the same branch, but I'm telling Claude to work on 2 different things at once. So this whole like, you know, terminal workflow works really well in my experience. Okay, so it's just finished this. Great question. Game engines are one of the harder domains to point an LLM at. Look at that. It is self-aware. And knowing exactly why is what lets you set up workflows that pay off. Let me give you a concrete framework, then offer to build the scaffolding for your actual stack. Be deliberate about where Claude, me, is strong versus dangerous for engine work. I like how strong is actually shorter than dangerous. See, this is what I'm talking about. Like, it's somewhat self-aware. I wonder if this is also using, obviously, the history that I have with it, because Claude stores like data in your user account that sort of applies to every use of it. So just because there's no like .claude directory with all the memories or information within this repository, because this is just a blank directory that I've made for the purposes of this video, it still knows stuff about me. It still knows how I've used Claude, and it's sort of saving stuff in its like kind of global memory that's tied to my user account. So maybe a lot of this is because it sort of knows how I use Claude. So I don't know. If you guys try this prompt, like let me know what you get. Okay, so there is a bunch of stuff here. I'm not going to go through all of this, but if I just scan through this, you can see that it suggests that you make a strong claude.md at the repo root. This is loaded every session and is where most mistake prevention lives. Put in it the non-negotiable rules, so like no allocations in hot paths, no exceptions in engine core, error handling convention, naming, memory ownership conventions, the module boundaries, the build test bench commands, and when in doubt about a graphics API, stop and cite the spec, do not guess. It's interesting that that's a specific thing that it picked. You can see it's also offering to set up skills and things like regression checks and sanitizer builds. So this is actually suggesting a really good workflow that is possibly better than what you would do yourself if you weren't using AI. And of course you weren't maybe experienced enough, or the project wasn't serious enough to warrant you setting this up. So this again ties me back to this whole like beginner mentality and how it's sort of ruining beginners. Like, yes, if you just have your overnight agents run nonstop and you're not learning anything and you're not writing code and you're not reading code and whatever else, like, yeah, I can see that being bad. But, you know, to a beginner, it's like, what is static analysis? Like, what is ASAN? What is undefined behavior sanitize? Like, what is all this? You're learning so much that you wouldn't really, you know, I didn't learn about this stuff in uni, like in university. That didn't happen. So this can actually be very, very educational. Architecture decision records is memory. So engines live for years and the expensive mistakes are architectural. When we decide ECS with archetype storage or bindless descriptors no per draw sets, record why. I have a persistent memory system for exactly this, so decisions survive across sessions and I don't relitigate or contradict them later. Also good advice. Anyway, there's a bunch here, and look, there's even like, it's even like, what was this? It's actually offering me. So what language is the engine in? Guys, I feel like we've just started the game engine series. Like, I didn't even intend to. C++. Oh yeah, I think that came up. People thought I might have been doing it in Rust because Let's Get Rusty is a sponsor of a lot of these videos. And whilst Rust is quite an interesting language, and I feel like I'm gonna probably end up making some Rust videos soon, to be honest, because I'm really curious and I haven't done like a proper deep dive into it. C++ is definitely still my preferred language of choice, and that's also what we're going to be using for this new game engine series. Which graphics APIs are you targeting? So we've got Vulkan, DirectX 12, WebGPU, Metal OpenGL, undecided, and then you can always type something. So I might say we'll use an RHI such as NVRHI. And then finally, stage. So where is the project right now? Yes, it is in fact empty. Submit answers. I didn't actually expect it to ask me this, but this is kind of cool. Anyway, while that is manifesting, let's go and open up a new tab. I'm gonna go back a directory into Hazel, which I've just checked out here. Let me just make this a little bit bigger. So if we go into Hazel here, this is the game engine series version of Hazel. So what I'm talking about, of course, is the Cherno/Hazel, which is the 2D game engine version of Hazel. The reason why I've picked this, again, just for a random example, is because it is quite lightweight, so it's not like huge. The real version of Hazel is quite big and it would just be harder to sort of demonstrate something quickly. And of course, there is no like .claude in here or anything. So this has not officially been used and then checked in with Claude. So it's like a blank slate. And it's an established existing project, so it's a good place to demonstrate some of the other ways that I like to use Claude, which is to generate reports. I love it when AI generates reports for me. So what I can do is say something like, write me a report, and save a token there. Write a report, save more tokens. This is actually reminding me of something called Caveman, which is like a plugin. If you're short on tokens, try something like this out. Why use many token when few do trick? This is something that kind of, well, yeah, will take your prompt and just make it a lot more sensible in a lot of cases, but also just get rid of like half of it. And you end up saving a lot whilst retaining technical accuracy. So if you're, you know, finding that tokens are not enough, as in you're running out of tokens a lot, try something like this. Anyway, Write markdown report. I like to say markdown, otherwise it just dumps it here. I want it in an actual file, and you'll see why in a minute, on how 2D rendering works in this game engine. Be deep and thorough. Compare to other engines. Find strengths and weaknesses. I'm just, making stuff up, to be honest. This is not something I thought about for more than 2 seconds before I started writing it. Find existing bugs to fix and suggest solutions, and give future direction. Convert markdown to PDF. Enter. Okay, so while we're getting a report here, let's go back and see what Claude did with our game engine series. Okay, so perfect apparently. That combination actually resolves the biggest risk I flagged. NVRHI is the container graph. We probably won't use NVRHI, by the way, but this is just an example that I gave. It abstracts these APIs behind a handle-based readable. Okay, I know what it is. I don't care about that. So concrete foundation, I'd recommend. So for toolchain, CMake, NVRHI vended as submodule, standard C++20. I don't know why I would probably use 23 to be honest. It's suggesting tests as well, so doc test or Google test, and benchmarks, nanobench or Google benchmark if you want the full feature set. Windowing, GLFW, sanitizers, like you know what I mean? Like this is a good tool chain. Like this is solid. This is something that will not only help you make sure that you're making a high quality product that maybe, is admittedly more on the serious end. If you were just doing this for fun, like you probably don't need half of this, and it's probably might not be might take some of the fun out of it, is what I would say if you weren't using something like Claude. But since you are using something like Claude, not only is this sort of stuff not a burden because you just get Claude to like write tests and benchmarks, for example, and do the sanitization formatting stuff, it also allows Claude to develop better. Because as it's developing things, it's actually running all of these tests. It's writing tests, it's running tests to verify its own work, and it can do that in a loop that doesn't even involve you. So basically, instead of just presenting you with something and being like, I don't know if this even compiles, bro, it's like, this compiles, this passes tests, this passes our performance targets. Right? And if it doesn't, it just goes back and fixes it and works on it until it does. So it's giving you, the human, with your precious time, a product that is just much better. Because what you definitely want to avoid is having to go back and forth with it 100 times, because the first time it gave you code that didn't compile, the second time it gave you code that was just horrifically written, the third time like it just didn't work, it crashed at runtime, the fourth time like it works now but it like performs really slowly. If you can avoid all of that and just have it kind of working on it behind the scenes, then that's the best case scenario. It gives you code that, again, you still read at the end, you still make sure that it's, formed in the way that you would like it to be formed, but it's at a state where it's been guaranteed to work and perform well. That's a much better place to be in. Okay, so we're obviously not going to start the game industries now and go through all of this, but I will say that when it comes to the way that it writes code, I can say something like, what about code conventions? Do they go in a conventions.md, or what do you recommend? Because this is also another really important thing. You want to be able to give, whatever agent is working on this. And by the way, this is going into like a .claude directory and into claude.md, but there's also like agents.md and other things like Codex can use those files. So the example I'm giving is just for Claude because that's what I've personally been using, and that's what everyone on our team has basically been using most of the time. But these concepts do translate to other agents. If I was you, I'd probably keep testing all of them, but I don't want to complicate things too much here, so we're just sticking with one. Okay, so this is cool, and this is actually kind of what I was hoping for. So it said that a conventions MD is fine, but the file name is the least important decision. What actually matters is which of 3 tiers each convention lives in, because in Claude code, where a rule lives determines whether it's enforced for free, loaded into my context every turn, or only read on demand. Splitting by tier matters far more than one big file. So this is perfect, because this is my whole point of just ask it. Just work with it to establish something that suits both of you, because this isn't like, some people picture this whole AI agent thing as like they have to go on Reddit, or they have to like, I don't know, this is actually a really good example. This whole Andrej Karpathy Claude.md, which by the way is not even written by Andrej Karpathy. It's just like some guy derived it from that, and yet again it has like, I don't know, 187,000 stars. This isn't about trying to go on the internet and find some like magic password that suddenly makes Claude perform better. It's really just all about you working on the workflow with Claude. You can always learn things. Like, I'm giving you some generic tips, but I'm not being like, just download this and it will fix everything. And, not to mention that downloading various skills or prompts or whatever could potentially be a security risk or might give you unintended behavior. It's honestly just better to sort of build your own framework that works for you and As you can see, Claude will correct you and help you actually do that. So this is actually really good. So tier 1 is mechanical tools and tool config, right? So formatting and naming, you can use these built-in tools because whilst AI can go through and sort of, I guess, run algorithms itself, like just being an AI model, that's usually quite an inefficient way to do things. And so even Claude will, for example, write a Python script that will do refactoring for it rather than having to go through every file and do it itself manually. So leaning on tools and setting up stuff like this is much better than just getting it to actually do that. So this is a great example of that. Back to our report. Oh, it's still going. You can see this is a longer range task. I mean, it's still not that long, but it's gone over here and it's produced a 2D rendering report.md. I like to have things in Markdown because LLMs love Markdown, and also Markdown can easily just be, previewed in something like VS Code and you'll see it rendered nicely. But PDFs are also nice to share with people, and I don't know, I just kind of like PDFs, but it's not always worth the conversion. You can see it's taking like way too long. Okay, cool. It's done now. It's found a bunch of bugs, by the way. It's also compared it to a bunch of things, which is cool. It's got a few things to say. Hazel's batching core is more modern than Sprite Batch, and its MSDF text plus per pixel picking beat most hobby engines, but it trails on sorting layers, atlases, 2D lighting, and multi-backend support. Okay, so if we just go start dot to open up this directory, you can see we've got 2 reports. Let's look at one of them, maybe the PDF version. Here it is. 2D rendering in Hazel, a deep technical report. Of course, we're not going to go through this. It's 9 pages, which is not too bad. Like, it's pretty in depth, but isn't this cool? Isn't it cool to just be able to run a report like this on a code base and get something that is, in my experience, mostly very solid? That's not to say that it never makes mistakes. It does make mistakes. But again, I am a software engineer who's aware of this code base reading this report. This is where the whole being a good engineer comes in, because I mean, sure, this is Hazel, this is my code base. So if it says something ridiculous, like I can probably immediately just be like, yeah, that's wrong, for example, right? But I do have it do reports on other things that I'm not aware of, or maybe I've cloned another repository and I'm interested in how something works there. I'll have it generate a report for me. How do I know that that's correct? Because I don't know the code base. Well, I don't, right? And there are 2 answers to that. First of all, there's the intuition of like, potentially questioning it, or, I mean, one thing that I didn't actually ask it to do, but it did anyway, is provide me with sources. So for example, vertices, like the vertex structure. It's told me that that's in renderer2d.cpp line 16. It's a 44-byte interleave struct. Here it is. And it's showed that to me, right? So I can go to the code base and I can actually verify that myself and reasonably trust that it's not just making it up. It's getting it from this actual source. Now, I could also tell it to make sure you include source code snippets for every claim that you make. And I have done that before, and that's been pretty successful. But anyway, I would say that I do this like 5 times a day or something. I actually have a lot of reading material. So yeah, I love my reports. And again, truth be told, in my experience, like they've been pretty good and pretty accurate. But just make sure that you use your own intuition, obviously, and that you also ask for proof or ask for sources and make sure that it's sort of citing everything that it's, every claim that it's making. Also, I guess I should also add that like engineers make mistakes. Like if I asked someone on my team to give me a report on something, how do I know that that's factually accurate? I don't know, man. People make mistakes. So does AI. Everyone makes mistakes. Okay, getting back to our kind of game engine example here. So this is our blank repository, right? This is the sort of new game engine series thing that we were playing around with. Now that I have this information, I could go to this directory and then make a Claude.md file, right? Wrong. You're not thinking with portals. What you do instead is you just talk to Claude, right? So write me a Claude.md for my game engine project based on our conversation and would be effective in delivering a high quality product. I don't know, I made that up. I'm just gonna let it do its thing because the next thing I wanna show you sort of relies on maybe this Claude MD being present. Actually, while it's working on that, let me also point out how to actually maybe work with it on a specific thing. So if we go back to our Hazel thing here, okay, this is another really good use of it actually, is like there's a README file here that tells you how to generate the Visual Studio solution and projects. And you just really just go in here and you run setup.bat, right? Like that's really easy. But I can always ask it, how do I run this project? I love this because you know, I'm not a web developer and there are like a billion web frameworks out there. So if I'm, I don't know, pulling some web repository, maybe it's like documentation for one of our products at Lucky Robots, and I don't really know, you know, how that's been set up, and I want to run like a local web server to preview the website, I just ask Claude. I'm like, Claude, run me a local server because I want to preview this. There's no like, you know, going in and executing like the exact commands to set up like NPM or give me some sort of like local server. I really don't even have to think about it. I just tell it to do its thing. And when I ask it, it tells me sort of how to do it. So I know what it's doing, and, you know, best case scenario, if I care, I'll learn something. I'm like, oh, it's using this framework. I didn't even know that. That's cool. But having Claude sort of give me that information is also really cool. So check this out. Not only has it, you know, identified what the project is, and if I've cloned recursively, so do I have submodules? Yes, that's actually cool. Maybe I accidentally didn't clone recursively and I try and run setup.bat, maybe it would even fail and be like, I can't find this. And then if I'm a beginner, I might be like, what do I even do? Like, it's sort of verified that for me, which is cool. And it's told me I've got everything installed, everything that I need. What's missing? Premake isn't downloaded yet, and the Visual Studio solution hasn't been generated. That's correct. So generate the project files. In Explorer, go to the scripts folder and double click setup.bat. So that is the thing that I just mentioned I need to do. It will download premake5.exe, it will do all of this stuff. Then I open the solution and build it. Like, how good is this? Put this into a building.md file for users. That's another thing I like to do with AI is write documentation, because, you know, like, this is a great job, right? Like, this is the thing, like, people love to hate on this stuff, but like, maybe it's not perfect, but you can always refine it. You can always just use this as a starting point and then just make it better. I find that it's a really good unblocker, because, you know, sometimes I'll sit down to write something like this as an example, and I'll be like, ugh, where do I begin? And getting started is like the hard part, right? But when you're already going, it's easy. So the fact that you can just get this to start for you and then work off of that is really good. And look, it's giving me great suggestions like, yes, link it from the README. Definitely very cool. So let's just say I'm working on Hazel. And actually, if we go back to that 2D rendering report, let's pretend we're trying to fix one of the bugs here. So over here, there is a heap overflow. No batch flush guard for circles, lines, and text. So draw quad correctly calls next batch when the quad buffer is full, but draw circle, draw line, and draw string do not. The circle guard is even present, but commented out. So if I want to fix this bug, now it's useful that I have the report already with the bug, so I know, I mean, I know a lot about it, to be honest, but let's just pretend I didn't. I just knew that there was like some crash or whatever. I could say that, and let's actually open up a new Claude over here. That is the wrong directory. We'll go back to Hazel and open up a new Claude, because I still want to keep all of this context potentially. If I'm trying to fix this bug, I could just say that, I don't know, it crashes when I draw too many circles, right? Like that's a prompt. But that's going to send it down a rabbit hole. It's going to probably take a really long time. It's going to use a lot of tokens. It's just not efficient at all. Or I could say this, again, working off of this. It's told me that there is a heap overflow over here in renderer 2d.cpp line 485. So I can literally say renderer 2d.cpp line 485, sorry. We haven't implemented next batch for circles. Do that. This is a lot more efficient than just giving it something random. And again, this requires a little bit more engineering. Look how quick it did that, by the way. It's been less than 10, wow. Okay, let's be honest here. I didn't know that apparently this was just commented out and it just works. I mean, I feel like it maybe jumped the gun here. I mean, did it? Will that actually work? So it was already implemented, it was just commented out. But anyway, you guys saw that that took 10 seconds. 10 seconds. If I had told it that first prompt, it would not have taken 10 seconds. And it would have used so many more tokens. So this is also really important. Make sure that you are as direct as possible. And the thing is, like, Hazel 2D is a relatively small code base. So there's no doubt in my mind that this would have worked. But if it's a really obscure bug in a really big game engine, it might actually not even find it. it might literally not be able to run through everything and like piece it together and work out why it's actually happening if you give it something so broad. It's just not going to be able to handle that. But if you're really direct, if you're really narrow with what you're telling it to do, and you as an engineer have put in some of that debugging, you can give it maybe more context, you can give it a call stack, you can give it some kind of log output that you've sort of put in there. That can produce drastically better results and might also be the difference between working at all and it failing to do its job. Okay, so it's given me some, so this was just chilling in Hazel. It was just to do implement for circles, but it was just off. I mean, okay, it did change the code a little bit. It changed it from quad index to circle index, but like, you know, obviously I could have just done that myself when I was programming. So it's a little bit of a funny example here. But anyway, it says that it's all good. And it didn't compile it, but again, this is like, I haven't used it inside Hazel 2D before, and there's no .claude directory with all of its, you know, workflows. So technically speaking, if I was doing this properly, it would have probably built it. Okay, back to here. So this has written me claude.md. If I bring it over here so that we can read it, let me just open this as well. So this is my claude.md that it's done. So game engine project guide, high performance C++ game engine. Rendering runs on this. Status green field, cool, golden rules, read first. Performance is a correctness concern, never guess an API, especially in VRHI. Plan before non-trivial code, work in small, compiling, tested slices, when uncertain, stop and ask. Commands, sure. I mean, again, we have nothing yet. This is in a blank repository. I want to point that out. So the accuracy of this is crazy because again, it's just like, you know, made stuff up. There's also a bunch of engineering conventions. This I would say is probably too much because ClaudeMD is something that gets loaded like immediately, right? So this already has everything here. And because inside example, you can see it's already made that ClaudeMD. If I was to spin up a new terminal, a new Claude instance, and ask it something like, what is this project? It's actually already gonna know. So you can see that down here, it was listing the directory and seeing what files actually exist, and it found the one file that does exist. But before it even ran this, it already said that the guide notes its green field, right? So that ClaudeMD is already loaded. It's already aware of all of this stuff. That might be too much information, because what you generally want to do is just have like sort of the important stuff that applies all the time here. But then if you have specific like guide points or something that, you know, is only relevant to something. So if you ask it to generate a report, for example, you don't want it to be aware of all of the testing and building infrastructure and how to actually do that. That's only relevant if it's writing code. If it's modifying the project, you want it to compile and test the actual code. But if you include it inside ClaudeMD, all of that is sort of being loaded all the time and it's not relevant and it bloats your context. And that's exactly where skills come in. So back over here, it's written the ClaudeMD, which is great. Shouldn't some of these things be skills? Let's actually just ask it that and see what it says. Again, I'm trying to kind of approach this as maybe one of you would if you've never done this before. In the meantime, we can have a look at that building .md file that it made for us. So like, check this out. This is pretty cool. And that's another thing that I like doing is when I'm talking to Claude and it's sort of given me something useful, like in this case, it's taught me how to build Hazel. I've asked it, how do I run this project? And it's given me all this useful information. I can just easily get it to turn it into something that is shareable or at least readable in the repository. It's like useful documentation. So that's also definitely worth noting. Okay, cool. So you can see that, yes, good instinct, and you've spotted a real flaw in what I wrote. I overpacked the Claude.md with a couple of things that are procedures, and procedures are exactly what skills are for. The dividing line, ClaudeMD, what's always true, and then skills, how to do a specific recurring task. So skills are quite useful. We will end up talking a lot more about skills and writing lots of skills as part of the Game Engine series, but I will show you one that I like to use. But let's see what it said. Propose project skills inside .claude/skills ranked by leverage, add render pass highest, encodes the NVRHI procedure. Okay, this is kind of cool. That's a cool idea, you know. New module, scaffold and engine module, directory, CMake wiring, nested ClaudeMD, test and bench stubs. It's also good. Add benchmark, golden image test. Oh, this is good. Add update review, a reference image, render a test. Image diff script bundled. That's really cool. New ADR, scaffold an ADR from a template, cheap, keeps it sitting. Yeah, so this is the architectural decision record that it talked about earlier with like its memory, how it can keep track of architectural decisions and sort of keep them there. So that's really cool as well. Don't skillify everything though. A skill only earns its keep when the procedure is non-obvious, must be consistent, or a bundle script does real work. Things I'd do correctly anyway don't need one. Yeah, that's kind of the problem though, isn't it? So one skill that I like to do is I have one in pretty much all of my projects that's /CR, code review. That is basically just going to go through all of the stuff that is not committed yet. So all of the unstaged or staged files that you have that have not been committed, and it's going to go through and check to make sure that it complies with our conventions, that it has been tested. There aren't comments that are like paragraphs big. It's all sort of concise. It's going to make sure that it's not duplicating code. That's another good one. A lot of the times an AI agent might just write its own hash function at the top of the file or something instead of using the existing engine API that of course has a variety of hash functions that it easily could have used. And to make a skill like this, again, just ask Claude to make it. Write a skill called CR, which is a code review. This checks all uncommitted files and makes sure that they comply with our conventions, our goals. They don't duplicate code. They use existing engine API. They extend engine API where appropriate, etc. Now, in reality, this is something that you would probably give a lot more thought to than I just did, but also it's something that evolves over time. When someone notices that like, hey, that might actually be really useful to have in like a code review, ask Claude to add that, you know, into your CR skill. There are lots of other skills. The possibility for skills is really endless, and don't forget that like, in a way you could treat them as commands. So because Claude is an agent that can obviously not just edit your code and run and test your code, but it can also, you know, interact with GitHub via CLI or something. You could literally make a skill called open PR or create PR that will make a pull request inside your repository with the branch that you've been working on or with whatever feature it's been working on, and then potentially run a skill like CR to make sure that the whole, you know, you might have several commits there, but all of the commits are like good and they meet quality standards, they've been properly tested. Inside the actual GitHub PR, like body, it could also even attach benchmarks and, you know, the main gist of what it's done and how it's been tested and why it's good. You can actually go pretty wild with this as well. I remember a few months ago, I made a skill inside our Lucky Engine repository that would basically automatically test the engine. It would just try and like write some Python code that would puppeteer the engine, like, you know, open a new scene, create some cubes, add some physics, record that happening, take screenshots when we hit play and they're supposed to like fall and be affected by physics. It would record that, then go through the video, verify if that worked. If it didn't work, it would actually try and find the bug and dig through the code, you know, via logging and other tools. And then it would, you know, fix itself, boot the engine up again, do that same test again, which is in a Python script. So it's like, it's very, very reproducible. And that's honestly something that you can just have it do in a loop. So yeah, the possibilities are kind of endless. So it's made that skill here now. So you can see it's in a directory called CR and it's got skill.md. You can invoke it with /CR and you can see it's actually even given me some options, right? So just like a command, you can do something like -- staged. You can add stuff like that for it. You can always ask it, how do I use the /CR skill? It will give you those options as well. But now after a restart, I can do something like /CR and you can see it's going to do all of that. I just hit enter. Obviously I have like nothing staged here. In fact, this isn't even a Git repository, funnily enough. So yeah, not a Git repo, but still per the skill, I treat the working tree as the change set. So I guess that's everything. That's that claude.md file. And then also the actual skill that we made. Cool. So there we go. It's obviously identified that there's no C++ engine code yet. There's nothing to review, but we are sort of creating all of that scaffolding to actually begin our project. Anyway, I think that like, whilst I've sort of talked about things that are hopefully useful to you, I mean, there's lots of stuff. Like you might have noticed I've got auto mode on. You can change it to accept edits or plan mode. Plan mode is also something I use pretty often if I'm actually trying to plan a feature, and then I can talk to it, have it definitely generate those reports for me, iterate on them, plan something properly, and then have it actually implement that plan. That's definitely important for bigger features, especially within an existing code base. There's lots of stuff we could talk about, but I truly believe that the best way to sort of do this is to actually work on a project, which is why I wanted to make that new game engine series that should start pretty soon. Anyway, I hope that this has been helpful to you. Don't forget that this also does apply to pretty much every AI agent out there, not just Claude. You can do the same kinds of things in Codex. Maybe actually practically looking at this has also helped convince some of you that maybe it's not that terrible, and maybe you can give it a shot, you know, and see what kind of results you get with some of these tips. And finally, as I mentioned, the way that I use this is not to replace me as the engineer or anyone on my team as the engineer. We use this as a tool. We are still very aware of all of the code that it writes because, quite frankly, right now, halfway through 2026, I still definitely do not trust it to just write code on its own that no one will ever read. For the purposes of, you know, high quality, high performance game engine like software development, it's just not there yet. It's just not there. But it has dramatically increased our productivity. And again, if you do have the appropriate scaffolding and tools in place and it's actually working the way that you've designed it to work, then it's amazing. Let me know what you guys think in the comment section below. Do you have other tips that you'd like to add to this? What has worked really well for you? What hasn't worked really well for you? Definitely let me know in the comment section below. Maybe I'll implement some of those ideas into the game engine series as well. Thank you all for watching. I'll see you later. Goodbye.